Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for joining us today. Welcome to today's general lecture on climate past, present, and future, adapting to climate change. Uh, Before we begin, I will introduce you all to our keynote speaker. Our keynote speaker is Professor Peter Gell from Federation Australia University. His main research is paleoecology, Ramsar wetlands, and climate change. He has received several research awards, including Hilary Jolie Medal in 2019, awarded by Australian Society for Freshwater Sciences. And for moderator today, who will guide us through the discourse, is Professor Dr. Tri Retaningsih from Department Biology, Faculty Science and Mathematics, Diponegoro University. Prof. Naning has 104 publications in reputable international journals, and her areas of interest is water quality and microbiology as bioindicators. First of all, we will have a welcome speech from Professor Muhammad Agung Wibowo, the Dean of School of Postgraduate Studies, Diponegoro University. Prof. Agung, please take the stage.
Yes. Oh. Yeah, thank you, MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, guest speakers, professor, colleague, and committee, and ladies and gentlemen. My name is Muhammad Agung Wibowo, Dean of Postgraduate Studies, Diponegoro University, the Honorable Head of Prodi, Pak Budi, the Honorable Prof. Naning, and also I would like to extend my warm welcome to Professor Peter Gell from Federation University, Australia. Let us all take advantage of this opportunity for the general lecture on the topic of climate past, present, and future, and adapting to the climate change. A big thank you to our organizing committee for putting all this seminar together and for all the hard work that have been done. Finally, please allow me to end this remark and by wishing you all of delight and informative talks and discussion. Thank you and enjoy the general lecture. Wassalamualaikum warahmatullahi wabarakatuh.
Before we begin, we will now have a group photo session. Photo session. Please stand up.
Okay, thank you, Master of Ceremony. Morning, Dean, School of Postgraduate Studies, and then Pak Budi, and then the Vice Dean of Academic. I think I have a look, who likes me. And then good morning also for all students of Master and PhD Environmental Science at SBS. It is our honors that today we have Prof. Peter Gell from Federation University that joined with us. Actually, he has in Semarang since 8th of September, and tomorrow will be leave from Semarang because we already have many activities. General lecture, also studium general in FSM, and then we are doing some field work. And 2 days ago, we went to Bedono to have activities with local communities in Bedono, and as well as I also invite PhD student that take my subject in DIL, and then I have a task for them to make small research. Yep, with the output something that might be able to increase the IQ. And today, Prof. Peter Gell will share the knowledge about climate change. Indeed, the climate change already happened, and Indonesia have been impacted. And 2 days ago, whenever we went to Bedono, it is not far from Semarang, but the condition is worse because every year many houses sink and become part of the oceans. And although the local community have certificate of land, but whenever the land had been changed into the sea, they didn't able to do many things. So Prof. Peter also have last year produced a book. He is a good writer in book as well as a journal, many books that already produced, and then many journals that also produce every year with a high citation. So we able to learn many things from Peter's. So you have plenty of time, take your time, and then I hope all the student, both offline or online, will be enjoy, and we will have a discussion later on. Time is yours.
I'm sorry, sir.
Better? Not clear. Just take this off. Okay, all right, we'll take this off. Is that better? Yeah? Okay. So 55 years ago, the world's climate scientists got it about right. And since then, we've spent a lot of money doing climate science, and we're refining, but we're realizing that, in fact, those predictions were under predictions. The scenarios for the future are actually worse and quicker than they predicted back in 1969. So the message I want to tell you there is that the world has known about climate change for longer than all but two of us in this room have been alive. So it is time to act. Now, this one.
Yeah, because in the Zoom it is not clear enough.
Next, yeah. So I want to impress on you that we know that climates change. So I have worked on paleoclimate. I've worked on this lake. In 1993, that's over 30 years ago, Patrick de Decker and I hosted the International Paleolimnology meeting to look at these lakes here in Western Victoria, not far from my home. And these lakes are like rain gauges. They go up when the climate gets wet, and they go down when the climate gets dry. And they get fresh, salty, and the fossil remains tell us about that history, as well as the sediments. So my history of climate goes back to 10,000 years in this instance. And here this lake was dry because the climate was dry. Then the lake rapidly filled and overflowed because the climate was wet. Then the climate dried out again and the lake dried. Then it filled again, not to overflow, but quite full. And now it's dropping now into the present. And the climate modelers can understand what is driving those large-scale changes we're witnessing in Western Victoria down near Melbourne in Australia. There is now probably 70 years of paleoclimate research. Ray Bradley here is one of the world's leaders, Patrick de Decker, Neil Roberts and others, Rick Forrester, Sherry Fritz all came to this meeting with us, and they were driving paleoclimate research in the world. Roger Jones's work looked at that very recent change over the last 150 years. That lake has gone from being 29 metres deep to 8 metres deep. The rain gauge is drying out. And he used modelling of the catchment to show that that lake, Lake Keelenbeat, one of the most famous lakes in the world, was becoming, well, what's happened there? I've touched the screen. Do I touch it again? Up.
So as always, we turn it off and then turn it back on again. That's the answer to everything. Oh no. Okay, I'll continue talking, but Roger Jones' work, who's an IPCC scientist. Everybody here has heard of the IPCC, I hope? Yep. He's a climate scientist, and he showed that that lake had either experienced a 15% decline in rainfall, 15, or a 15% increase in evaporation, or a combination of both, in 150 years, in only the last 150 years. So that's a substantial change in rainfall, effective rainfall, relative to the 10,000-year record I showed in the previous slide. Okay. Next slide, please. Is that the next one? And we know here from the Murray-Darling Basin, again, some of Roger's modelling, that with future climate change, we can see changes to runoff in Australia's biggest catchment. So the Murray-Darling Basin is 6 times the size of Java, and it has 14,000 gigalitres of runoff per annum. But if we have 2 degrees of increase in global temperatures, plus a 15% decline in rainfall as modelled by Roger, then that catchment will lose up to 50% of its runoff. So Australia's breadbasket, where most of our food is grown, will lose in the order of 7,000 gigalitres of water supply. So this is a major challenge for the Australian government, ensuring we have water into the future. Back to, we missed one. I thought this was beforehand. And so in terms of past climates, sorry, this preceded the Murray-Darling Basin slide. It's now, modellers have now been working on what's driving climate variability. Roger showed a drying climate, but we know we have variability. We know ENSO, Southern Oscillation, El Nino, La Nina. We also have a multi-decadal oscillation. That works. It's called the Interdecadal Pacific Oscillation, or the IPO, and it operates on 30 to 50-year cycles. The IPO index is in white, and you can see rainfall goes up when the IPO is negative, and vice versa. Rainfall goes down when the IPO is positive. And it's about the circulation of the Pacific Ocean and how that affects regional climates. And Australia is very much controlled by this oscillation, as well as La Nina and El Nino, and as well as the Indian Ocean Dipole. Have you heard of the Indian Ocean Dipole? Increasingly, there's been more evidence of the Indian Ocean Dipole, which is the balance of sea surface temperature between the Indian Ocean and Java, let's say. Okay, so what does past climate tell us about Southern Australia's climate? A regional drying began 100 years ago. And that shift is significant at a 10,000-year scale, because it's about the size of change that occurred in that 10,000-year record. Since European settlement, there has been significant additional driver of climate with greenhouse gas emissions, and that's put us outside the pattern driven by another model called SAM, the Southern Annular Mode, which for southern Australia tells us how close the Antarctic westerly winds come up to Victoria. So that's been pushed south. So the high pressure system is increasingly over southern Australia, and we lose wet season rainfall. So it's quite predictable. Future rainfall decline of 15%, which will take us to 30%, which is quite extreme at the long-term scale. And so the change from La Nina to El Nino will become more intense. The multi-decadal cycles will continue, but there will be a drying trend. So in the future, our rainfall will do this. Sorry, down. It'll decrease, but it'll have variation in it. I was reading this morning that the Australian government is saying that El Nino, La Nina will become harder to predict because of the higher sea surface temperatures. So they're not using the past climate anymore to predict the future climate because the climate is changing so much. So they're having to be very versatile in terms of their climate forecasts. So what do we know about global temperatures? We still have many people in Australia that are sceptical that temperature is increasing. This is the reconstructed temperature for the world over the last 1,000 years, averaged across the whole world. We have the medieval warm period here, the little ice age here, and here we are in 2000. Okay, we're off the charts. So present temperatures are exceptional relative to the last 1,000 years. And these reconstructions are from tree rings and coral reconstructions, as well as speleothems in caves. Okay, you know, stalactite, stalagmite, you can reconstruct climate by drilling into the stalactites and the stalagmites. And these have been repeated multiple times all around the world over 2,000-year reconstructions. There is an Asia 2K you can look up, which gives you the temperature for Asia for the last 2,000 years. And that puts you in context for the temperature that you have today. Again, what's called the hockey stick is this rapid change in the last 100 years in terms of global temperatures. And I'll remind you that 2023 and 2024 were the warmest temperatures across the planet for over 100,000 years. So here are the temperatures, actual temperatures versus modelled temperatures. The modelled temperatures are the dashed lines based on carbon emissions and methane emissions, and the solid red line is the actual temperature. And this data is 10 years, 15 years old now. So we know this, that temperatures are tracking higher than even the models are saying. Temperature anomalies, here we are in Australia, 2010, well, that continues out to here. It's continuing to increase from down here all the way up to here. Globally, from down here all the way up to here, it's continuing to increase. 9 of the last 10 warmest years were in the last 10 years. 9 out of 10 were record years. It can't be coincidence. Carbon dioxide concentrations. The last glacial interglacial range for the last 700,000 years is between 180 parts per million and 280 parts per million. It just went like this, glacial interglacial. In the Ice Age, it was 180. In the interglacial, it was 280. In the Ice Age, it was 180 for 9 cycles. Okay. Today, it's at 424, which is way outside the range of 180 to 280. The last time carbon dioxide was at 424 parts per million, was in the Pliocene 4 million years ago, when sea levels were at least 10 metres higher than today. 10 metres higher than today. We are on a track to go outside the Pleistocene in terms of climate. It's increasing at 2 parts per million per year. Global emissions. Actual emissions versus modelled emissions. Again, these are the modelled emissions with low emissions in dashed line, high emissions modelled in solid line, and the black is the actual emissions. And so since 1990 through to 2005, we were following the high emissions pathway. The world has done very little to reduce carbon emissions. Carbon dioxide continues to increase. As you see here, continues to increase rapidly. So the IPCC has had many reports, many meetings. We've had global crisis meetings, and yet we're not doing enough to reduce emissions. Some people might suggest that this is due to the sun, because there's variation in insolation due to sunspots and the like. Here is, from 1975 to 2005, solar cycle variations. There are variations, there is no trend. Here we have surface temperature record, which is increasing, despite there being no trend in solar cycle variations. Mount Pinatubo eruption caused global temperatures to reduce because of the dust that was put into the atmosphere, reflecting light back to the outer atmosphere, keeping the surface cooler for a number of years. But very soon we're way up here in terms of temperature anomaly. So we're on this pathway despite solar variations, and here we have solar variations, here we have carbon dioxide, and here we have global temperature. So we can partition out volcanoes, solar activity, and human carbon emissions from the drivers of global warming. This is the influence of solar irradiation, that little one there. This is the influence of greenhouse gases. Dust in the atmosphere actually reduces the temperature, and the net effect by humans is here. So the smoking gun is the bulk of the climate change we've experienced since 1960 is attributable to human carbon emissions of fossil fuels. This is the future we're facing because we're on the fast-track pathway to a warming world. Here is 2050. Temperatures are extremely high, less so in the tropics because it's fairly warm already, but extreme increases in the Northern Hemisphere land mass. Mitigation. The Paris Agreement talked about a 1.5 degree limit, and that was driven by the people in the Pacific Islands who are likely to go underwater if sea level rises too high. Unfortunately, we're at about 1.5 degrees already. So the Paris Agreement target is, watch it out the window as we go past, effectively. I know many climate scientists that have given up on 2 degrees already because we're going so fast in that direction and we're not mitigating carbon emissions. For mitigation, rich countries must, by 2020, so that was 4 years ago, okay, reduce by 25 to 40% below their 1990 emissions. They have not done that. That statement was made 15 years ago. We missed that target. So I'm saying now emissions must peak very, very soon, no later than by 2030. That originally said 2020. I've changed it to 2030 to make up for the fact we haven't done anything. Here's the committed greenhouse gas warming. Antarctic ice loss. Greenland ice sheet loss at 2 degrees. We get up to 3 degrees, we lose the Amazon rainforest. We get up to 4 degrees, we lose the thermohaline circulation, which protects lands from cold and hot temperatures. Effectively, above 2 degrees, we lose control of the global climate. So we need to abide a reduction in emissions. So in terms of mitigating carbon emissions, if deforestation peaked at 2015, and it didn't, but halved by 2040, and it likely won't, and was eliminated by 2060, and if agricultural carbon emissions peaked at 2020, which it didn't, and reduced to stable levels by 2050, but accepting 9 billion people on Earth, because that's where we're headed to, carbon dioxide emissions will need to have peaked by 2020 and reduced by 3 to 4% per annum from 2020 onwards. We've missed that plan. Perhaps 6 to 7% to compensate for developing countries who will be slower to reduce their emissions. 5% was the economic collapse of the USSR. That's an enormous change in gross domestic product to achieve a 2-degree outcome. And that's very optimistic. Would that hold us to 450 parts per million? No, because we'd probably add another 3 billion tonnes of greenhouse gases to rise to 550 to 650 parts per million, generating a 4-degree rise. So I'm trying to impress on you that we've got governments who've got targets for 2050, 2030. They're nowhere near good enough to avoid us experiencing the worst. We need to adopt these sorts of changes. We're still going across here. So if we add 2024 there, we've actually got to come down steeper than was predicted for 2020. So if we don't reach peak emissions till 2030, we probably have to reduce our emissions by 10% per annum to hit a target by 2050 to try and keep to 2 degrees Celsius. 3/4 of climate scientists in Australia were polled, and they said, on average, they thought we'd end up at about 3.5 degrees Celsius. Okay, that's losing control of the global climate. So why is it so urgent? Gradual increase in temperature, we can put up with another degree. Outside today, it's pretty warm at 35. 36 doesn't matter that much. 37 is probably even okay. But there are global tipping points, which are the major risk to global warming. A tipping point is when a point is exceeded and the system shifts to a new state. So it can vary, increase in variation, and suddenly it goes, whoa, it's over here. Changes into a completely new state with new feedback effects. One of those is the fact that when we lose Arctic ice, the surface of the Earth goes from white to dark. And dark surfaces absorb more energy. Ice reflects light. Sea absorbs light. So we will transition from a reflective surface to an absorptive surface. And that's going to be a permanent change because it's a feedback which increases temperatures. Polar warming in the northern hemisphere thaws the permafrost, and locked up in the permafrost are huge volumes of methane gas. Methane gas is 80 times more effective in trapping energy than carbon dioxide. So the more it thaws, the more it warms, the more methane is released, the more the temperature goes up. That's a tipping point when we get to that point. And a similar function in the oceans with buried methane as clathrates. If the ocean warms, it'll release more methane. Already people are suggesting that the Gulf Stream, the Atlantic meridional overturning circulation, is beginning to retreat backwards. It goes from the Gulf up here and it keeps Western Europe warm. It's a warm current at the surface. It'll start diving because it's becoming more dense. And so England and France and Norway will not get the warm seas that they did, and their temperature will drop from 10 degrees to 2 degrees. And England will be almost uninhabitable because it won't have any warmth. So we're getting to the point where we're changing global oceanic circulation and we don't know what's really going to happen. At 450 parts per million, we'll lose control of the climate. If it's 424 years now and it's growing at 2 per year, how many years have we got left? 13. Yeah, we've got 13 years to reach peak carbon emissions, or we've lost control of the global climate. And who knows what will happen. So sea level projections, which is probably more relevant to somewhere like Semarang. Sea level is presently rising at about 3.3, 3.4 millimetres per year. And it will do that for every year. But as you can see, that is accelerating. And that's just from melting. The ice scientists don't know the effect of melting on the physical loss of ice. At the moment, huge ice blocks are being undermined by melting, and they might all just slide off Greenland in one event. We could have huge catastrophic ice shedding events in the future, which will raise sea level considerably. It's suggested that sea level rise by the end of the century will be at least 140, potentially 2 metres of sea level rise. That'll flood Florida. That'll flood Belgium. That'll flood a lot of Indonesia. All the islands in the Pacific, apart from Hawaii and places like that, all those low-lying islands will be gone, and those Samoans and people like that will have to migrate to New Zealand or Australia. Their land will be lost. That nation will be lost to the world's list of nations. And already in the UK, they're identifying these sorts of effects of sea level rise on towns in Cornwall. Huge storm surges with higher sea levels. So what other effects are there? The Stern report said that with 2 to 3 degrees warming, and that's if we halt at 40 in 13 years at 450 parts per million, 30 to 200 million people will be at risk of hunger. We're probably seeing that in Northeast Africa already. We're probably seeing that in the Middle East, and it's driving, that and drought is driving war in the Middle East. For an additional 3 degrees, for greater than 3 degrees, an additional 200 to 500 million people in hunger. 70 to 80 million more Africans exposed to malaria, and 1/6 of the world's population exposed to dengue fever on account of increasing global temperatures. So we are witnessing this change now. We need to reach peak levels by 450, which gives us not that many years, 13 years as we've calculated. Massive fires in the US, Canada, Australia, Greece, today in Portugal and Spain. 4 years ago, Australia had a fire that was 14 million hectares of southeastern Australia. We've seen Kalimantan in fire. Will Java burn in the dry season with higher temperatures? As I said, July 2023 and 2024 were the two highest global temperatures since the last interglacial 120,000 years ago. Before people came this way. People left Africa 60,000 years ago, and the temperature has never been as warm as it is today since that time. Floods in Pakistan, Australia, China, US, Semarang on March the 15th, Europe, as we're seeing this week. Cyclone Yagi in Vietnam, the Philippines, China, etc. And these increasing incidents of hurricanes and typhoons this year. I went to Mexico in June, July. I arrived in a hurricane and I left in a hurricane. It's going to be the biggest hurricane season in Caribbean ever this year. Drought, Australian drought, US drought, North African droughts. Extremes of climate, coastal inundation. You're not alone. Jakarta, 20 centimetres a year. Shanghai, Venice, Miami, all experiencing huge levels of coastal inundation. The city of Miami got a surprise. In a sunny day like today, water started coming up the drains. And they didn't know where the water was coming from. It was coming from the sea. Up the pipes, up the drains, onto the roads in downtown Miami. So downtown Miami is being flooded due to coastal inundation, whether it be through subsidence or sea level rise. Coral bleaching. Australia's Great Barrier Reef will be gone by 2 degrees Celsius rise. We're only half a degree from that. We are having massive coral bleaching. It won't be worth visiting the Great Barrier Reef in 20 years' time. And ecotourism industry will collapse on account of that. And that's multiple billions of dollars of income to Queensland. Glacial retreat we're seeing in the Himalayas, Canada, New Zealand. We're seeing lakes that were going down starting to come up because they're being fed by unprecedented glacial melting. Winter ice loss in the Antarctic. All the sea ice around the Antarctic is melting at unprecedented levels, impacting upon the ecology of the species that require that ice. Widespread ocean warming. We had an El Niño in Australia last year, but the sea surface temperature offshore Melbourne was 3 degrees warmer than average. And so it defeated the El Niño drying effect. And we actually had a wet December and January, unprecedented wet December and January. So we're getting sea surface temperatures which are making it very difficult to predict what the implications are of El Niño or La Niña. Climate scientists are struggling to keep up with the impact of global surface sea temperature warming on climate patterns. Changing ocean currents. Because of diminishing sea ice around the Antarctic, we're getting an Antarctic burst across southern Australia at the moment. It's 10 degrees in my hometown. We've had it as low as 8 recently, and we've had huge winds and lots of rain on account of a change in ocean currents and air circulation on account of ice melting. And storm intensity. Every degree of warming leads to a 7% increase in absolute humidity of the air. So the air carries more water. The increased heat also increases the intensity of the uplift in a thunderstorm, meaning more intense rainfall and greater water volume in rainfall. That's why we're getting such massive storms with huge, unprecedented floods. It's because the increasing temperatures hold more water and the storms are more intense. And this is what we're witnessing in 2023-24. But we're looking at another degree of warming or more if we don't arrest global emissions. So, societal response. Mitigation. We need to reduce carbon emissions. It's certain that the burning of fossil fuels, that's fuels that weren't being recycled, fuels that were buried as oil, buried as coal, buried as gas, are being brought into the carbon cycle, and they're pump priming the effect of energy trapping by greenhouse gases. There can be no more fossil fuel projects. Zero, finished. We need to transition rapidly to alternative energy. I've been here for 10 days and I haven't seen a solar panel in Semarang. I'm sure there are, but I haven't seen one. Australia has solar panels on 3 million houses, which is about 1/3 of all houses in Australia now have solar panels on them. I haven't seen one in Semarang. Transport. We need to transition from oil, e-vehicles, hydrogen. You're in a technology industry. We need to encourage this technology to come to the fore very quickly. We've got 13 years, remember. Semarang is a city planned for the car. I tried to go walking and there are footpaths you can't walk on. You have to venture onto the road with risk of getting hit by a truck just to get around a power pole. Semarang is designed for cars. We need to design it for public transport. The environment. We need to revegetate to sequester carbon. We're still looking at huge deforestation rates around the world, particularly in the tropics, but also in Australia. We need to protect our wetlands, particularly our coastal wetlands and our soils, and allow them to build carbon, to sequester carbon in wetlands and soils. So I was in northwest US and I happened across this sign on a display from Thomas Edison. You must know of Thomas Edison. In conversation with Henry Ford. For those who can't read it, we're like tenant farmers chopping down the fence around our house for fuel when we should be using nature's inexhaustible sources of energy, sun, wind, and tide. I put my money on the sun and solar power. I hope we don't have to wait until oil and coal run out before we tackle that. Okay, that statement was made in 1931. An observation by one of our science leaders that unfortunately wasn't listened to. So we're at 424 parts per million. There is inevitable climate change on account of the greenhouse gases we have in the atmosphere today. It's almost certain we're going to get to 2 degrees Celsius, and that will create regional catastrophes in terms of those impacts we're already seeing. So we need to prepare our society for the impact of what will inevitably come. So we need to prepare for dangerous climate. We need to prepare better for wildfire. At the moment, 10 years ago, California and Australia used to share helicopters to fight fires. And fighting teams used to go from California to Australia and back again because of the change in season. Summer there, winter here, summer here, winter there. Now the fire seasons overlap by 4 months. They've still got fire in winter. and our fire starts in spring. So we can't get any more people from California because they're still fighting their own fires and can't come to Australia to help us fight our fires. So we need to find ways of dealing with wildfire that we haven't up until present. Intense storms and flooding. What would happen if Cyclone Yagi came through here tomorrow? Is Semarang prepared for a cyclone or a typhoon like that? What happens when everybody in lowland Semarang is underwater? Where do they go? Who looks after them? How do you raise the funds to repair their properties? Where's the human rights if there's no protection for people when we know these cyclones will come? Extreme heat. You're going to get days here of 40 degrees, 42 degrees. There are some places in the world, in the Middle East, that have recently had 56. You can't be outside in 56 degrees. Where do you go? Where's the place where hundreds of thousands of people can go under air conditioning to keep themselves alive for an extreme temperature outbreak? We're not prepared in Australia, but we need to be prepared because otherwise people are going to die. There are people dying every heat wave now. Climate refugees. There are people going to leave countries. There's going to be millions of people, migrants, moving because their country is no longer habitable. Where do they go? Germany doesn't want them. Italy doesn't want them. Britain doesn't want them. Donald Trump doesn't want them. We've got to work out where these people go. They're going to have to move. Millions and millions and millions of them. To say nothing of the biodiversity impacts. Many of our species won't be able to withstand the temperatures that will prevail in 10 or 20, let alone 50 years' time. So we'll see massive biodiversity impacts, and we need to reduce the human footprint so our biodiversity can withstand the upcoming climate changes. So what sort of adaptations are possible? Food production, there's going to be huge crop damage. Interestingly, with global warming, southern Australia has just had a really big frost, sub-zero temperatures. But that happens when things are dry. And there's been a reduction in 25% in the wine industry. So there's going to be crop damage on account of climate variability and climate change. Extremes of temperature, extremes rainfall events, hailstorm events on fruit and the like. Are we prepared for that? Are we prepared for flooding and collapse in the production of rice paddies through long-term inundation or long-term drought for that matter? So we need to think of heat and drought-tolerant crops and ways of keeping some lands free of flooding so that we can keep producing under climate extremes. We need to diversify plantings because there's going to be an increase in disease of crops. So if one crop dies through disease, you've still got other things to drive your food economy. So diversifying plantings and mixed farming approaches will help you be prepared, increase your adaptive capacity to increasing changes to the climate. Biodiversity. I'll just focus on aquatic biodiversity because Professor Nanin and I are in that space. The Living Planet Index has said there's an 81% decline in freshwater biota since 1970. The decline in marine biota and land biota is about 33%. In freshwater biota, it's 81%. But we don't notice because they're underwater. And the aquatic megafauna, the turtles, the dolphins, the frogs, the fish, are among the greatest risk of extinction into the future. So we need to think about aquatic biodiversity and greatly reduce our footprint on wetlands to allow our aquatic systems to adapt to the future climate change. And at the coast, Reduce causes of subsidence. If you've got an 8 centimetre a year subsidence in Semarang, you're not going to be ready for a rising sea levels. You must address subsidence to have any chance of dealing with global sea level rise. And you need to track that back to the source of subsidence, which is the over-abstraction of groundwater for drinking water. You need to retain habitat at the coast and renew habitat by planting, for example, mangroves, and generally reduce pressures on the aquatic biota. The fish catch in the world is far too great. We need to find other ways of producing protein for the planet's people that don't impact so heavily on fisheries. Here's an example of an adaptation that people in Britain are already considering. It's called a staged managed retreat from the coast. We pick up houses and we put them up the hill. There's a town in Wales in the UK where they're planning to have that town removed by 2050 because it will be underwater. Pick up the town and move it up the hill. And this will have to happen in thousands of townships that are within a metre of sea level today. So we need to be prepared, and we need to adopt what's called adaptation pathways to our new future. What do we need to do? When do we need to start doing it? Because we're going to have to move thousands of people in Semarang somewhere else. We can't just build the road up and keep building the house up, because a storm will knock it all over eventually. People will need to be moved unless we control subsidence. So that heading is there is adaptation in Semarang. Sorry, it's missing. There we go. Climate adaptation in Semarang. Address subsidence, number one, I would suggest. Flooding. We are channeling our rivers in Semarang. That moves the water more quickly from the top of the catchment to the bottom of the catchment. If you've got sea level rise or if you've got a high tide, that increases flooding at the coast. You need to retain water in the catchment for as long as possible and therefore reduce catchment efficiency, slow down runoff, not increase runoff. And you need to have more flood retention basins that fill up when the flood comes to try and slow down the runoff and the flooding in the bottom of the catchment. Extreme heat, we need an urban forest. You can see trees out here, but for much of Semarang, there are very few trees. It's a very hot walk if you try to walk around Semarang. That's why everybody's in their air-conditioned cars. But we need urban forests for cooling, and we need to create those cool refuges that I mentioned. Drought, we need to diversify water supply. You might get extreme droughts. You'll get extreme floods and storms, but the opposite might also occur. Will Stephan, who is a IPC scientist, said the whole system will just be pumped up. Droughts will be more extreme, floods will be more extreme, temperatures will be more extreme, wind will be more extreme. So we've got to be prepared for the extremes. So diversify the sources of water so we can have water when it's not raining. Sea level rise. Even if we control subsidence, the world's going to have 1 to 2 metres of sea level rise by the end of the century. And you need to plan for that now. You're putting in infrastructure now, it has to be 2100 ready. Part of that's natural protection, which is the replanting of mangroves, a natural passive coastal protection measure. And intense storms, you'll get intense storms, but you need good warning systems so you can get people out of dangerous places so they don't drown. They're not washed away in cars. And they need somewhere to go. There are places that were flooded 3 years ago in Australia, and the people who lost their houses still haven't got a house to live in. They're living in a caravan. So we need to find means of finding alternative accommodation for thousands of people. And so there needs to also be a very prepared emergency response. There are people in Australia that had 30 minutes of a record flood warning. They had 30 minutes to get out of their house. 30 minutes later, their house was washed down the river. We need to have warning systems, and we need to have an emergency response to pick those people up and get them to safe ground. So here we are in Semarang. There's lots of things in Semarang that we need to consider under these climate scenarios. And I enjoy coming back here, and I enjoy seeing the challenges that you're facing. You have challenges that are you've wrought on yourself through various management practices. You need to go to other parts of the world and see what they're doing to try and reduce the impact of human development on catchments, so that you can bring ideas to Semarang and convince the government to invest in ways of reducing your footprint and preparing for climate change. So in Australia, it's drought and fire and storms and flooding. In Java, it could be anything. Here's number one, Jalan Bardjo that we saw the other day. That house there has gone. That house is gone. That one's gone. And that one's gone. I wouldn't want to be selling a property in Bardjo at the moment. You wouldn't get much money for it. So there are climate change matters that you need to deal with as soon as possible. Now, I wasn't going to venture this far, but I think I might. You are postgraduates in environmental science or science generally. I've just painted a picture of what you're facing and what the world is facing over the next 20 years, 30 years. I don't see in Semarang any environmental protest. I don't see in Semarang any signs up saying, walk, don't drive. I don't see any interest in people looking at sustainable, climate-ready alternatives to the future. You are the generation that are going to have to lead this. I was a climate activist when I was 15. I've been doing this a long time now, okay? You're the generation in Semarang that need to tap on your local member, and you know who they are. Their pictures are all up on the streets at the moment. We see them everywhere we go. You need to go to those people and say, do you know about climate change? And do you know the risk that we're facing in Semarang? And if you do, what are you doing about it? Because as we calculated, we've got about 13 years left till we're at 450 parts per million, and then the planet has lost control of the climate. I'll leave it there. Any questions or comments?
He is expert on paleoecology that use sediment record. Jadi whenever we collect the sediment from lakes, it is look like diary books that able to tell us about what happened in the catchment area. And then climate change, based on that data, the climate change had been proved it has happened, and how we have to develop mitigation and adaptation related to the climate change. So any comments or questions from you, as well as from the audience that join online? If you have any questions, you able to write down or you able to speak up. Silahkan.
Everybody is interested in what an immediate thing you might want to do. Our Lord is the global program of climate champions. You can look up climate champions, and you can volunteer to be a local climate champion who advocates for climate mitigation and climate adaptation in your local area. For the local program and mitigate and adapt to climate change. So we got climate champions.
Questions? Yep.
Yeah, bagus lagi bermakna.
Okay, good morning, Professor Peter. I want to ask you about the energy transition. How effective is the energy transition to reduce the carbon emission, according to your opinion? Thank you.
Very possible, very. Okay, Australia has very people, 40% and nearly all that has been in the last 5 years. So, Australians have taken on the message, and individuals are investing in rooftop solar. We are now closing down coal plants in Australia. They are stranded assets. The big banks are putting money away. Sorry. Usually I have my mother's voice. It's usually loud enough. So Australia is moving away from coal. We're saying we are going to have gas as a transition fuel between coal and renewables, but there's a lot of political pressure not to do gas, because gas itself is a greenhouse gas. And the problem with gas is you have all the fugitive emissions, which is emissions from the ground during the extraction process. It's not necessarily the gas that you use in your house. It's the extraction process emissions are really important. But also gas is very unhealthy. So they've found towns that have shifted away from gas have a huge reduction in asthma, because people get asthma when they're cooking with gas. So it depends on the will and it depends on the politics. So I'm not seeing any politics in Semarang, so you're starting down here. But somewhere, someone has to impress that coal is finished. And it's not enough to say that wealthy countries like Australia and America and France and England have to do all the work. Those countries are investing enormously in alternative energies. China is investing enormously in solar. It's also got coal, but it's got 1.3 billion people, so it's got to provide a lot of energy to a lot of people. So there are a lot of countries, and Australia uses more per person, if you include our exports, than any other country in the world. But we are transitioning very rapidly because it got into people's heads that we have to do it. So start the movement today. They're closing now, yes, rapidly. There's no, the next election will be about whether we have any more coal mines, and we'll be phasing out coal mines. So we'll have no more coal mines by 2035. But we are still exploring for gas. But the political pressure is increasing, and I'm sure we won't have either gas or coal by 2030. But government, the coal and oil industry are subsidised. Why are we using our money to subsidise an industry that's threatening our future? Why don't we use those subsidies to allow you and you and you and you to put a solar panel on your roof? So it's politics. And the oil and coal industries are very effective at influencing government. I was in a talk in London by Michael Mann. He was the person who did the first of those hockey sticks, okay, in 1998, I think it was. He gave a presentation in London in 2006. Got up and asked a question, and he said to me afterwards, "Oh, that person asked me a question when I was in China last week." So the oil and coal industry pay for people to follow him around the world to ask questions in his talks to try and make out that he's not telling the truth. So there's all sorts of intellectual suppression that goes on, funded by the oil and the coal industry. We need to know these sorts of details because your future and your children's future are at risk because of the oil and coal industry. And it's not dissimilar to the tobacco industry. And I can see you're losing against the tobacco industry in Indonesia. Australia, we have now only 15% of people smoke. It used to be over 50. Next to nobody in my age group smokes anymore at all. A packet of cigarettes here, how much? 10,000 rupiah? 30,000 rupiah. Yeah, it's between 60 and 80 Australian dollars for one packet of cigarettes in Australia. And that's all tax. So we've taxed people. If people want to smoke and they want to do 5 packets a week, it's going to cost them $300 to $400 to do so. So they've stopped smoking. And that reduces our health bill. Okay, so we need to find similar incentives to get Indonesia to transition from coal and oil to alternatives. And when I come back, I want to start seeing solar panels on roofs. Because what's wrong with the weather? Nothing. Why haven't you got any solar panels on roofs? They should be everywhere. And they're becoming very cheap. And with your technology, you can make them yourself. So there is a solution there to be had, but you need to convince your politicians that it's important enough. And I don't think anybody's knocking on their door at the moment. So your environmental scientists at the top Central Java University, isn't it you that should be leading this? Professor Nunning can retire soon. It's not up to her. You're the ones that are going to have to influence politics in Indonesia if you want to avoid the worst of the scenarios that I've painted today.
Thank you, Prof. Peter. So I want to ask, as we know, Indonesia government has now begun to make various effort and also effort to tackle climate change. And the initiative have been implemented, one of which is by ratifying the carbon trade policy based on your perspective. Sorry. How effective is the initiation of carbon trading in Indonesia as a strategy for mitigating climate change? Does it present in the context of national environmental policy and sustainable development goals?
Yeah,
Thank you.
I'm not an economist, but I will draw on Australia's history here. Australia has had 30 years of climate wars. Our conservative politicians don't believe in climate change, and our progressive politicians try to do the right thing. Kevin Rudd tried to bring in a emissions trading scheme that wasn't passed. Then Julia Gillard brought in a carbon tax when she said she wouldn't. It was very effective. Carbon emissions in Australia started declining very rapidly because there was revenue for people that reduced their emissions. So it was very effective at changing behaviour in Australia in a short term. Julia Gillard lost government, and Tony Abbott, the new Prime Minister, axed the climate tax, and our carbon emissions started going back up again. A carbon tax, carbon trading is absolutely essential to stop subsidising fossil fuels and to draw investment in alternative non-polluting energy sources. So we need to impress on our economics students to work on carbon tax models, carbon pollution reduction schemes, carbon trading schemes, to convince government that this is what's needed as a mechanism to get industry to invest in the alternatives that don't bring about those sort of futures. Yeah.
Thank you, Prof.
Hello, is that anyone that should join in the Zoom meeting? If you have any questions, you able to write down or raise your hand.
I have a question, Prof. I think. I'm so sorry.
Yes, sila.
Okay. Thank you for the topic. I think it's some very credible. I have a questions for Prof. Peter. My voice is clear.
Yes, please.
Okay, I'm so sorry. My name is Hidayat. I'm from Jakarta. By the way, I have example for the coastline in Jakarta, the North Jakarta. I think Indonesia is an archipelagic country. Then the impact of global warming is felt on Indonesian coastline. So, what is a more concrete solutions to prevent global warming from getting out of control in Indonesia, especially in the coastline in the North Jakarta? So, because we have a coastline in Jakarta, not only in Jakarta but also in Indonesia. So, what the solutions for the other country in the world? So, give the solutions for Jakarta. Actually, thank you.
The solutions to subsidies.
Yeah, especially in North Jakarta. Yeah.
North Jakarta. Okay. Well, I was reading about North Jakarta just the other day. I'll start with Semarang, and Professor Nunning, Olia, and I and a colleague in the UK have started to write a paper on solutions to subsidence in Semarang. And instead of building polders and barriers at the coast, I think one needs to look at the causes of subsidence, and that appears to be principally excess abstraction of groundwater, and that's also the case in Jakarta, I believe. So both cities need to find alternatives to groundwater, and I know in Semarang the shift to groundwater occurred because of the declining quality of surface water. It was too poor to be treated to bring up to potable water quality. So we've proposed 5 steps, again, in an adaptation pathways approach. Some things you can do immediately, other things will take time. So the first step is to stop abstracting groundwater and to import water from countries that have sustainable water supplies. That will cost money, but you need to stop subsiding as soon as possible. So you need to stop abstracting as soon as possible. Step 2 we've suggested is small upcatchment reservoirs that are high enough up the catchment for the water quality to be sufficiently good to be treatable for drinking water, to offset against the loss of water from groundwater abstraction. You have 2 metres plus of rain here, and that goes down the drains into the channels into the sea. We need to find technologies that can capture that water off roofs, put it into small water tanks decentralised across the city, which have multiple filter systems so that people can go and fill up their their water container, not a single-use water container, but a multiple-use water container from a rooftop. And that is a substitute for bottled water from groundwater. Another alternative then, in the longer term, is to work on the catchment's water quality to reduce pollution, to try and bring surface water quality up to a level where it might be treatable to provide large volumes of water for drinking. If you manage to achieve that in some catchments, you can use those large volumes of water and inject them back into the groundwater once they're treated to try and pump up the land surface in Semarang, not only reducing the subsidence, but actually bringing the land surface back up. Groundwater injection occurs in Adelaide because Adelaide has a very dry season and enough rain in winter to fill up groundwater aquifers. So they fill up the aquifers in winter and they draw down the aquifers in summer. So groundwater injection technologies are already well practiced around the world. So there are 5 steps we've identified to address subsidence in Semarang and complement that with coastal protection through polders perhaps, but through mangrove restoration once you've got the subsidence under control. In Jakarta, there are multiple drivers. Groundwater abstraction is one, but the weight of city buildings is another, and roads, I suspect, and groundwater use for other purposes. So it is multifaceted. I know plans for the new capital city, Nusantara, but Indonesia will have to do something with Jakarta. And I suspect, again, it will have to substitute groundwater for other sources. And I suspect that improving Jakarta's groundwater, because it's 12.5 million people, will be a much greater challenge than doing so in Semarang. So I'm not too sure whether the measures we propose for Semarang will be effective at the scale of Jakarta. But you have to try, and I don't think if you're subsiding at 20 centimetres per year that you've got any chance of arresting that through hard infrastructure at the coast. You will ultimately go underwater. So I think you've got to go back to the excessive use of groundwater and find means of substituting that for other sources.
Yeah, thank you, Professor Peter and Prof. Naning. Thank you very much.
Thank you, Pak Awan. That any other questions from online? From this room? Ya, namanya ya.
Good morning, Prof. Peter Gell. Maybe my English is not good, so I use Google Translate for help me to make a question. My name is Fauzia Debratna from Master of Environmental Science, Universitas Diponegoro. We know that deforestation is one of the causes of climate change. Data from Ministry of Environment and Forestry of Indonesia shows that deforestation still happen every year in Indonesia. Deforestation is happen because infrastructure development is still ongoing as in Indonesia. Recently, the construction of IKN, Ibu Kota Nusantara, the new capital of Indonesia, has also led to land clearing, which automatically cause to deforestation. So, is it difficult for developing countries like Indonesia to avoid deforestation because infrastructure development is still ongoing? And what do you think about this? And how we Indonesia to solve this? Thank you.
Yes, the deforestation in Kalimantan for Nusantara is a consequence of subsidence in Jakarta, which is a consequence of pollution in Jakarta's catchments from poor land management in the first place. So yes, you're chasing your tail, as they say, okay? You're not solving the problem. I think, and there is an element of the IPCC discussions around rich countries funding developing countries to adapt to climate change. If you go to California, you can try and grow a tree and it'll grow that high in 10 years. In 10 years, a tree in Java. So if we're going to grow trees, we need to grow them in the tropics. But if we're going to grow trees, we shouldn't chop them down in the first place, because the ecological value of a tree is greatest when it's tall and old. And so we need to protect the last old growth that we have, even though they're not sequestering carbon at the same rate that young trees are. So Indonesia could well stop subsidising the extraction of timber from the last of its old growth rainforests. That's a political decision, but political decisions have got to come from people. But it could also encourage developed countries to fund Indonesia to restore its landscapes, to increase its forest stock. And at the moment, a lot of that support in Asia is coming from China. And I'm not entirely sure of China's motives, but they aren't always in the interests of arresting climate change or improving biodiversity. So it may well be that the major funding bodies come from the World Bank, IMF, the US, European bloc, and to a degree Australia and Japan, to offset the bad environmental practices in those countries. So it's a mixture of things. I think Indonesia has to be responsible for itself, but I also think under climate change mitigation, there are strong moves to have countries like the US and others pay developing countries to improve their practice with respect to forests and carbon emissions. Good. Thanks for the questions.
Thank you, Professor Peter Gell.
Thank you for the question. I will ask you, sir. Semarang is, divided into two areas, the Lower Semarang and Upper Semarang. In the Lower Semarang area, the amount of land with trees is very small compared to the total area occupied by buildings. The question is, how can the green area in Lower Semarang can be increased given the limited available land? And additionally, can green building solutions be applied in densely built areas without altering the existing structures? Thank you.
Well, it can simply be done by you telling your local member, your local politician, that you think there should be an urban forest because of climate change. It's in the planning process. If trees are not in the planning process, you won't get any trees. So in the development that you've got down at the coastline, if you haven't got the government if you're not pressuring government to invest in trees in planning, then you won't have any trees. So it comes from the pressure of what they need to do. And they need to go and see cities where there are trees. There are cities all around the world that are saying, oh, it's getting hot here. I mean, northern Sydney, the temperature will increase by 6 degrees Celsius. And people are now living in houses with square sides, with no eaves, and they rely entirely on the air conditioning to keep cool. They won't be able to live in those in 20 years' time because they won't be able to afford to buy the electricity to pay for the air conditioner. So these people are going to live in hot slums. So you're asking the people, 1 million people on the flats in Semarang, to withstand the heat by running air conditioners, which are powered by coal, which are creating the problems in the first place. So you need to argue the case to your politicians that the sensible thing to do, an inexpensive solution to the heat that we're going to face, is to plant trees along all the roads. And clever botanists like yourself will know which plants will survive in the difficult conditions in the industrial and residential places in lowland Semarang. Do you know the species? Which species of tree to grow? The casuarina might be one. Oh, don't grow gum tree. Don't grow eucalyptus, please. Find a local tree that has fruit for birds. Don't grow eucalyptus. Javan birds don't know how to use eucalyptus. Use native trees that can withstand those conditions. But you do that by pressuring your government to pressure the planning process to make sure all development has trees. We're environmental technology. Does anybody know a technology that gets carbon dioxide out of the atmosphere that's better than a leaf? Isn't a leaf the best technology to get carbon dioxide out of the atmosphere? Have we designed anything that does it better? Carbon capture and storage doesn't work. we've not designed anything better than a leaf to get carbon dioxide out of the atmosphere. So we plant trees everywhere. Okay.
I think we already have 2 hours class with Prof. Peter Gell. And whenever you still have any questions, he's still in Semarang until tomorrow. Or you able to send a message to me and I will forward it to Professor Gell. And as well as for the audience that join in the online, whenever you have questions, I able to deliver your questions to Prof. Gels. And there is a question from the audience, is that they're able to get your PPT. So I have to take your permission first before we distribute it to the, yep. Okay, so the PPT, we will convert it into PDF because it is a big file. And then as well as all of you, you able to have the PPTs and I will send to Mbak Andri. Thank you, Prof. Peter. And
.350.org. Okay, that's a campaign to get carbon dioxide back to 350. Remember, we're at 424. We've got a long way to go to get back to 350. If we get it back to 350, we've got control of the climate again. So look up 350.org.
Do you still have last statement for the students?
Oh, well, that's it. Yeah, join in the campaign.
Okay.
We need people. We need the campaign to be worldwide, and I think Indonesia. There are people in Indonesia who are campaigning. You need to find them and join them, and build the Indonesian campaign. And good luck.
Thank you, Prof. Peter, and let's give applause to Prof. Peter. And don't forget to join 350.o. Yep, .o, and then share with your friends, colleagues, and then because you have Instagram, you have Facebook, and then you also have to be a leader to campaigns, to involve campaigns. Thank you. Itu Pak Budi ada. Yeah. I will deliver the times to the Master of Ceremony.
Thank you, Prof. Peter Gell and Prof. Naning for these valuable insights. Thank you, everyone, for participating. Next one, we will have a handover of certificate from Mr. Budi. Oh, Prof. Naning. I think that's all for today. I hope you found this session informative and inspiring. Have a nice day. Wassalamualaikum warahmatullahi wabarakatuh. We will have another photo session here. For Zoom participant, can you please turn on your camera because we will have a photo session. Thank you everyone for participating.